In this problem, we're going to find V0 using mesh analysis. And if we look at our circuit, we see we've got one current source. And when we assign mesh currents, we assign one to each mesh. And if you'll note, there's 1, 2, 3 meshes. So let's assign our mesh currents as such. So now we have 3 mesh currents. I1, I2, I3. We're going to need 3 equations. And since we have a current source, we know we're going to have a constraint equation. So our constraint equation is going to be I2 minus I1 equal to 2 milliamps. So with our constraint equation, I2 minus I1 equal to 0.002. Okay. Now, we need 2 more equations. We will go in and apply KVL to any mesh that doesn't have a current source. Well, the only mesh that doesn't have a current source is mesh 3. Okay, so let's apply KVL to mesh 3. If we do that, we'll have 3K times I3 minus I1. Drop across here. We'll have 6K times I3 minus I2. Drop across this resistor. Then we'll have plus 6K I3. Drop across this resistor. Minus 8 equal to 0. And if we collect up terms, we'll have minus 3K I1 minus 6K I2 plus 15K I3 equal to 8. There's the second of our 3 equations. Now we need one more KVL equation. We did our constraint equation, which gave us 1. We did KVL around this mesh. It didn't have a current source. Now we need to apply KVL one more time. Here's our circuit. Here's our assigned mesh currents. And what we're going to do is we're going to do a super mesh. So you can think about replacing this current source with an open and looking at some loop formed in the circuit. So for instance, we could do the outside loop. Okay, so if I think about this being open, think about a super mesh that goes around the outside or a loop. So if we start here and go around, start with the 2K, we have 2K I1 plus 3K I1 plus 4K I2 minus 12 plus 6K I3. We come back around, we'll have minus 10. It's equal to 0. And if we look and collect terms, we'll have 5K I1 plus 4K I2 plus 6K I3 equal to 22. Okay, here's our third equation. Now we're ready to enter the equations in MATLAB and solve. So here's our constraint equation. So now this is plus 1. And using MATLAB, we get I1 equal to 0.4762 milliamps. I2 is 2.4762. I3, 1.619 milliamps. Notice that our constraint equation checks here. And if we look back at our circuit, we can certainly see that V0 is 6K times I3. And it's 9.714 volts.